So 28, we have an object on object of mass 2 kilograms, starts from rest. Okay, so V initial is 0. Starts from rest and slides down an inclined plane 80 centimeters long in 0.5 seconds. So the length, we'll say that it started up here, so it slides down 0.8 meters. That's the length of the incline in a time of 0.5 seconds. The question is, what net force is acting on the object as it goes down the incline? Okay, this is super easy to find because why? What's the equation for net force? F net, the total force on an object, is always equal to what? Ma. And what's another way of saying that? Another way of saying net force equals Ma, you could also say sum of the forces equals Ma. Those are identical. F net and the summation of the forces are identical. Okay? So, look. Do we really have to do a free body diagram here? We don't. Let's do it just to be, super thorough, but we really don't need a free body diagram. All we have to do is what? What's the thing we got to solve for here? So looking at F net equals Ma, they're asking us for the net force. They're asking us for the net force. Do we have the mass of the object? Yeah. All we got to figure out is what? The acceleration. So how do we find the acceleration? How could we get the acceleration? With a kinematic, with one of the motion equations. So we were told V initial 0, we got the displacement, and we got the time. So to find the acceleration, I would just go x equals 1/2 at squared plus V initial t. The first kinematic on the list. V initial is 0, so you take what's left. So A is 2x over t squared. So you're going to go 2 times 0.8 meters divided by 0.5 seconds squared. So this gives us an acceleration of 6.4 meter per second squared. So what must the net force be? F net equals Ma. The mass is 2 kilograms. The acceleration is 6.4. So net force comes out as 12.8. Hey man, which way is the net force? They don't ask for it here, but which way is the net force on this object on the hill? Is the net force pointing down like that? No. Is the net force pointing up like that? No. Is the net force pointing to the left like that? No. Is the net force pointing to the right like that? No. Which way is the net force pointing, dude? Which way does net force always point? In the direction of what? Of the acceleration. Look, F net, net force, and acceleration are always in the same direction. Always. So which way is the net force on this object? Down the incline. Acceleration is down the incline, so net force is down the incline. And what is the net force specifically? What is the net force specifically? Well, let's look at it in more detail here. So here's the incline. Some angle. They don't even give us the angle. It doesn't matter. Okay, here's the object. So what are the forces on the block? Mg down. Normal force up. There's the normal force. Do they mention if friction is present here? No. It doesn't matter. The net force the net force can be found just by going F net equals ma. So let's just say there's no friction. Let's say there's no friction for right now. So on an incline, the thing you want to do is consider the incline to be the x, perpendicular to the incline is the y. You think of it like that. So normal force is nice because why? Normal force points perfectly where? Y. How about mg? Is mg perfectly x or perfectly y? Nope. So what do we have to do to it? We got to break it apart. So I'll use the red pen. So right there is mgy. Right here is mgx. Okay. Guys, what is the net force? I've done the free body diagram. I mean, we know the net force is, what did we get? I forgot the answer. Whatever it was, we already calculated it. We know what the net force is, but on this diagram, what is it? Is the net force going to be the normal force? Is that the net force? No. Is the net force going to be mgy? No. What's the net force? It's the x component of mg, right? Now, what if friction were present? Just hypothetically, what if friction were present? Which way would friction be going? Back like this. There's friction. Now what would the net force be? The net force would be what? It'd be mgx minus friction. But how did we find it in this problem? I mean, I think I'm making it a little more difficult than it needs to be. But this is important. I mean, understanding what the heck net force is. You know, if there's no friction, then the net force is simply mgx. If there is friction, then the net force would be mgx minus the friction. But either way, you know, what's net force always equal to? Ma. Thanks. All right, any questions on this? All right, let's do the lab.